We're really excited about not only comparing some of our data to the data that was taken over 50 years ago from the time that we actually arrived at Venus, but also to take brand new measurements that were never taken before.
Why atmospheric probes? How come no one wants to do a lander? Or, what are the complications of doing that?
Oh, there are many of us in the community that would love to do some sort of long-lived lander. There are some additional technological issues that come into play there in preparing for it. It's a lot less complicated than a lot of people think, but it's still very complicated to do. And so in some ways, sending an atmospheric probe that is a short term is going to be much more feasible for now. And in the meantime, there are many groups of people that are working towards coming up with new ways to explore the planet, including, long-lived landers, but also long-lived atmospheric things like gliders and blimps type of materials.
Well, I've heard it takes a very long time to get to Venus, even though, the distance between Earth and Venus is much smaller than the amount of time it takes to get there, because you can't go straight. I guess you have to slingshot around and do all kinds of maneuverings to get there. Like, what's that like to get a probe to Venus?
I took an orbital mechanics class in graduate school, and to be honest, I loved the class, but I was also happy that it's not something that I went in to do. But so it does take a couple of months to get to Venus because of what you just mentioned. You kind of have to slingshot around, especially if you're going to be, if you're really interested in setting yourself up to either drop a lander or, drop a probe, or even go into a specific orbit versus conducting a flyby. There's a lot of orbital mechanics that you have to work through, but it's actually fairly quick. It really only takes a couple of months to potentially get into position.
Months still. I mean, that's, if you were able to quote unquote fly straight there, has anyone calculated how long it would take versus how long it takes now?
Oh, I'm sure that calculation is out there, but I don't have it off the top of my head.
No problem. So what do the probes want to measure? You have data you said from 50 years ago. Is it accurate? Is it inaccurate? And what's it missing that you want to get from a new probe?
Oh, yeah. That data is, accurate. And there's still a lot of ongoing work that's being conducted, analyzing that data past what was done, at the time. But we're also going to be able to take, 21st century instruments back to the planet. So some of the instruments that Da Vinci is going to bring are actually 5 instruments from within our descent probe. We have 7 instruments in total, but 2 of those will be on our spacecraft, conducting measurements as we fly by the planet. But in terms of our descent sphere instruments, we have 2 mass spectrometers. One is called VMS and the other is VTLS. And they're going to be taking analytical chemistry type sips of the atmosphere as it descends. So they're going to tell us, what the atmosphere is like in terms of chemistry, going to be measuring, some isotopes and noble gases that are going to be able to tell us about the history of the planet, as well as what the current conditions are. And it's going to be able to do that throughout the entire descent. So it's going to tell us about any potential gradients that exist within the atmosphere. Then we have
also get a vertical over time look at what the atmosphere is like at different heights.
Yeah, absolutely. And then we have 3 other instruments. We have our Venus Atmospheric Structure Investigation, which is called VASI. And that's going to be taking all of your, fundamental measurements of the atmosphere as we descend. So things like temperature, pressure, wind speeds. So the stuff that we need to know to put the rest of the measurements in context. Then we have VFOX, which is the Venus Oxygen Fugacity Sensor. And that's going to be taking the partial pressure of oxygen, especially near the surface. And that's going to tell us a lot about the mineralogy and the chemistry of the surface and atmosphere, near environment. And then our final one, which we're really excited about, in addition to the other very exciting instruments, is VINDI, which is our Venus Descent Imager. And it's going to be able to take first time ever spectrographic images of the surface from below the clouds. Now, all of these other types of IR measurements that we have been taken from from orbiting spacecraft. And that's what we are able to determine the composition and the topography of the surface from, are those, orbiting imaging, or like the orbiting IR measurements. But we'll be able to take those measurements from, again, under the clouds. So, and we're doing this over a tessera region. And so we're going to be able to take these measurements and compare it to the measurements that are being taken from the orbiting spacecraft, and be able to excruciatingly fine detail over the tessera, but then extrapolate outwards for the rest of the planet.